All right, in this video, we're going to talk about section 5.1. Chapter 5 deals with integers. So pretty much we're going to be talking about the basic operation of integers over two sections. In section 5.1, we're going to look at first addition and subtraction of integers. And in this video, we'll talk about how to recognize the meaning of integers, represent integers on a number line, apply models for addition and subtraction of integers, and recognize properties of addition and subtraction of integers. Okay, so let's talk about representing integers and what they are, what they look like. The set of integers is going to be denoted by a capital letter I. There are some textbooks that use the capital letter Z to represent the set of integers, but here we're going to use I for the set of integers. And it consists of positive numbers, negative numbers, and zero, as you can see here from this set. Positive numbers, negative numbers, and zero. And of course, the negative integers are going to be opposites of the positive integers. Like, for example, -4 is going to be the opposite of +4. And also 3 is the opposite of -3. Okay, so let's look at this example here. Let's say we want to find the opposite of x. In other words, here we got x is equal to 3. We want the opposite of x. Well, to represent the opposite of x, it will have to be a negative sign in front of the x. And if we put the negative sign in front of the x, then that means that this 3 will have to be -3. So the opposite of x equals 3 would be -x is equal to -3. And in part B, x is equal to -5. Well, let's do the same thing here. Put the negative sign in front of the x. And if we do that, then for the -5, we have to put the negative of -5, which means that -x is equal to, well, the opposite of -5 is 5. So it's written like this: -x is equal to 5. And then for x equals 0, we can put the negative in front of the x. But of course, the opposite of 0 is 0. And the reason for that is 0 is neither positive nor negative. Again, 0 is neither positive nor negative. All right, now let's take a look at this homework example here. We want to simplify the opposite of -3 if we were to read that correctly. So the opposite of a -3 is simply going to be 3. Okay. All right, next we'll look at absolute value. The absolute value of a number A, and it's going to be written as A with the vertical bars on the outside, that's going to represent the distance on the number line from 0 to A. Absolute value is the distance that number is from 0 on the number line. So in this case here, if I want the absolute value of 4, here, the distance from 0 to 4 is 4 units. So the absolute value of 4 is 4. And then for -4, well, -4 is over here, but from -4 to 0, that distance is 4 units. So the absolute value of -4 is 4. And do keep in mind that absolute value will always be either positive or 0. Absolute value will never be negative because of the definition of the absolute value. It's always the distance that number is from 0 on a number line. Now, here's the formal definition of absolute value. It's this: for any integer x, the absolute value of x will be equal to x if x is positive or 0, if it's greater than or equal to 0. And then the absolute value of x will be equal to negative x if x is less than 0. That means if x is negative, you'll do the opposite of that negative, which will change it to a positive. Okay, so let's look at some examples here. Like the absolute value of 20. Well, 20 is 20 units from 0, so that means the absolute value of 20 is 20. And then the absolute value of negative 5, that's simply going to be 5, because negative 5 is 5 units to the left of 0. And of course, the absolute value of 0 is 0. It's always going to be the case. Then the absolute value of negative 3. Well, let's bring over this negative sign that's on the outside. Take the absolute value of negative 3. That's 3 units to the left of 0. So the absolute value of negative 3 would be 3. And then you got that negative in front. So your final answer there will be negative 3 when you simplify it. Now, here we got the absolute value of x plus negative 5 is equal to 1. Okay. Now, if you recall from your days in taking algebra, the absolute value of x equal to some constant, which I'm going to call a, you have to write that as 2 separate equations. X is equal to a, or x is equal to negative a. So for this answer, for part E, the absolute value of x plus negative 5 is equal to 1. You have to write that as 2 separate equations. One would be x plus negative 5 is equal to positive 1, or x plus negative 5 is equal to negative 1. Okay. This goes back to algebra when you're solving absolute value equations. You have to write them as 2 separate equations. And it's going to be written like this. And each equation you will solve for x. Okay, so for the x plus negative 5 is equal to 1. Well, the opposite of negative 5 would be positive 5. So I'm going to add 5 to both sides. I'm just adding the opposite on both sides of the equation. Now, the sum of a negative 5 and a positive 5, that's going to be 0. The sum of the negative number and its opposite is 0. So you'll be left with x equal to 1 plus 5, which is 6. Or, and then for the x plus negative 5 is equal to negative 1, we're still going to add the opposite of negative 5, which is 5. And I'm going to add 5 on both sides. So here x is equal to negative 1 plus 5, which will be 4. So that means x is equal to 6 or x is equal to 4. Questions on that? Well, if you have any questions, do feel free to email me. I'll be happy to help. Now for this example, the opposite of the absolute value of negative 13. Well, there's a negative sign in front, so I'll go ahead and bring that over. Let's do the opposite of the absolute value of negative 13. Well, that's 13 units to the left of 0. So the absolute value of 13 will be 13. The negative sign gives us the answer of negative 13. Okay. All right, next we'll look at how we can represent integers. And that's by using the chip model. That's one technique that we can use to represent integers. In the chip model, positive integers are represented by yellow chips and negative integers by red chips. One red chip neutralizes one yellow chip or makes a zero pair. The integer -1 can be represented by one red chip or two red and one yellow, or three red and two yellow, and so on. Similarly, every integer can be represented in many ways using chips. So in this case here, -2 is represented by the two red chips, as you can see, or you can represent, I'm sorry, 2 is represented by the two yellow chips, or 2 can be represented by a red and a yellow along with two yellow chips, because a red and a yellow will make a zero pair. Positive 2 can be represented this way. Here we can create zero pairs by pairing a red and a yellow and another red and a yellow. That forms zero pairs, and you'll be left with two yellow chips. Same thing here. You can make a zero pair with one red and one yellow, another red and one yellow, and another red and one yellow. You'll be left with two. Now for -2, two red chips represents -2, or three red and one yellow. Well, the yellow chip will form a zero pair with a red chip. You'll be left with two red chips, and so on. Okay, another model would be the number line model. Here, integers can be represented on a number line. We use a cat to walk the number line in this case. Different textbooks use different objects to walk the number line. Many classrooms have a number line on the floor for their students to walk the number line to represent whole number integers. So for walking a number line, here are the rules here. You always start at 0 and always face the positive direction or to the right. If a number is positive, you're going to walk forward, or if a number is negative, you walk backward. Okay. Now here's an illustration of that on the next page. Okay, for this one right here. Because if you see for 4, you start at 0 and face the right and go to the right 4 places. And then for -6, you start at 0, but go to the left to -6. All right, so this number line on the top where the cat starts at 0 and goes to the right, that represents +4. And this represents -6 on the number line. You start at 0, but you're going to walk backwards since it's negative. You're always going to face to the right. But when you get to -6, you have to walk backwards to represent -6. Okay, so that's how we use that number line model to represent numbers like +4 and -6. All right, now there's also the charged field model. Similar to the chip model, we use positive integers to represent, to represent positive integers, we use the plus sign, and negative integers are represented by the minus sign or negative sign. Positive charges also neutralize negative charges. So I got 3 positive charges and 1, 2, 3, 4, 5 negative charges. A positive and a negative form a zero pair. So I have 3 zero pairs that can be formed. I'm left with 2 negative charges. So this represents 3 plus -5 equaling to -2. Okay. And then you have your integer addition models here. Hands-on materials can be an aid when working with integers. Several models are presented to illustrate integer addition. So, again, we can use various manipulatives to help us do integer addition. Okay. Now, the chip model for addition is this. To illustrate the addition of -4 plus 3, you place 4 red chips together with 3 yellow chips. Because 3 red chips neutralize 3 yellow ones, we are left with 1 red chip, or -1. So as you can see on the next page, here we got 4 red chips, and then we got 3 yellow chips. Those 4 red chips represent -4. The 3 yellow chips represent 3. And here we have a 0 pair. So this forms a 0 pair. This forms a 0 pair, and that forms a 0 pair. You're going to be left with -1 chip, or -1. So -4 plus 3 equals -1. Okay. And then for the number line method, that's another model for adding integers. And here we use the idea of a cat walking the number line. So the rules here are you always start at 0 and always face the positive direction, or face the direction to the right. If the number is positive, you're going to walk forward, or if the number is negative, you walk backwards. So in this case here, that first number line that you see here represents 3 plus 5. So here we start at 0 and go to the right 3, and then we're adding 5. So from 3, we go ahead and go to the right 5, facing in the positive direction. And we end up at 8. So 3 plus 5 would be 8. Now this next one represents -3 plus 5. Now we still face in a positive direction starting at 0. But for -3, we walk back 3. And then we add 5, so we go to the right. From -3, we move to the right 5. And we end up at +2. So -3 plus 5 would be 2. All right, now this next number line represents -3 plus -5. -3 plus -5. Now here we stay at 0. Well, we start at 0, facing in the positive direction, but we're going to move back 3 places. And then we're going to add -5, so that means we're going to move back another 5 places, still facing in the positive direction on the right. So that means we're going to end up at -8. So -3 plus -5 equals -8. And this last one represents 3 plus -5. Now, we still face the positive direction to the right. We move to the right 3, but we're adding -5, so we're still going to be facing to the right, but we're going to be moving backwards 5 places, and we'll end up at -2. So -3 plus -5 ends up being -2. Okay. All right, now here's an example involving a thermometer with a scale in the form of a vertical line. Like in this case here, the temperature was -4 degrees Celsius. In an hour, it rose 10 degrees Celsius. what is the new temperature? Okay. Now, if we was to write that as an addition sentence, we started at -4 and it rose. So that means we're adding to it 10 degrees. Okay. So if it started at -4 degrees Celsius, then that means it rose up 10 degrees. It ended up at 6. So this -4 plus 10, which would be 6. So the new temperature would be 6 degrees Celsius. 6 degrees Celsius. All right. Next, we'll look at the pattern model. So beginning with whole number facts, a table of computations is created by the following pattern. So like here's some basic facts here for 4 plus 3, which is 7, 4 plus 2, which is 6, 4 plus 1, which is 5, 4 plus 0, which is 4. And then we continue this by, as you can see, we're decreasing the second number by 1. So we go past 0 to -1. So like -4 plus 1 is going to be 3. So as we decrease the second number by 1, the sum decreases by 1. So like -4 plus -1, that'd be 3. And then 4 plus -2, which is 2. 4 plus -3, which is 1. 4 plus -4, that's 0. 4 plus -5, which is 1. And 4 plus -6, which is 2. So pretty much you'll see the second number decreases, the sum decreases by 1. So here you can see the type of pattern that is found when you're doing integer addition. Okay. Here's the definition of addition of integers here. All right, so here if we let m and n be any integers as described. If m is any integer, then 0 plus m, which will be m, or m plus 0 will also be m. Now, if your m is greater than or equal to 0 and n is greater than or equal to 0, then the sum of those two, m plus n, is just defined using the addition of whole numbers as you normally would. Part C, if m is greater than or equal to 0 and n is greater than or equal to 0, then -m plus -n is just going to be the negative of the sum of those two numbers here. Now, if n is greater than 0 and m is greater than or equal to n, then here you got m plus -n, which is the same as -n plus m. That's going to equal to m minus n. And finally, if n is greater than or equal to m and m is greater than or equal to 0, then it's going to be this, m plus -n, which is the same as -n plus m, and that's going to be the opposite of n minus m. Okay. Now, this might be a little bit complicated to understand, but here, if you put this in words, according to the Common Core standards, here, this leads to integer addition using the absolute values here. And it says here, if you have to add two integers with the same sign, you're going to add the absolute values of the integers. And the sum has the same sign as the integers being added. In other words, adding two integers with the same sign, you just add the integers and keep the same sign. Now, for two integers with different signs, you're going to subtract the lesser absolute value from the greater one. And the sum has the sign as the integer with the greater absolute value. In other words, if you're adding two integers with different signs, you're going to subtract and give the answer the sign of the larger absolute value. So in this case here, -7 plus, let's say, -6. We got integers with the same sign, adding two integers with the same sign. So we're going to add 7 and 6, that will give us 13. And it will carry the same sign because they're like. Well, let's say something like this, -7 plus 6. We have two integers we're adding together. The signs are different. So we have to do 7 minus 6, which would give us 1. The sign of the larger absolute value is negative, so the answer has to be negative. So -7 plus 6 would be -1. Okay. And here's a definition of integer addition using absolute value here. In this case here, m and n are going to be integers described. If m is any integer, then that integer m plus 0 will be m, or 0 plus m will be m. If m and n are non-negative integers, then pretty much you just go ahead and add m and n together, just like you would for the sum of whole numbers m and n. Now, let's say m and n are negative integers, then that means m and n would just be the opposite of the sum of the absolute values m and n. That just follows the fact that if you're adding two integers with the same sign, you keep the same sign and add the two together. Now for here, if m is a positive integer and n is negative, then m plus n is defined as follows. Let's say the absolute value of m is greater than or equal to the absolute value of n. Then you'll have this. So basically, you'll just be, subtracting, and then you're going to take the sign of the larger absolute value. That's what all of this is saying. All right, now let's look at some properties of integer addition. And it says integer addition has all the properties of whole number addition. Okay, so if we're given A, B, and C as integers, the closure property states that A plus B is a unique integer. So -7 plus 6, I would get a unique integer, in this case, -1. The commutative property of addition of integers. Well, I can add A and B together and get the same thing as if I was adding B and A together. Okay, so in the commutative property, the order does not matter. For the associative property, the grouping does not matter. It's not going to change the answer. I can add A and B together and then add C to it. It's going to be the same as if I added B and C together and then added A to it. And then your identity property is this. The unique integer is going to be 0, where for all integers A, 0 plus A would be A. And there should be an equal sign there. So it'd be A plus 0, which is also going to give you A. Yeah. That right there is an equal sign. All right, now the associative property, the additive inverse property says if I have an integer and its opposite, the sum of those two is going to be 0. Of course, the additive inverse is the same as saying the opposite of that number. So the integer itself plus its opposite will always be 0. Okay. And here's a theorem. Of course, if you have the negative of -A, which is actually the opposite of -A, that's going to be +A. And then the addition property is this. of equality. Addition property of equality means if A is equal to B, I can add the same integer on both sides, and still both sides would be equal. And also part C, negative A plus negative B, that's like adding two integers with the same sign. That would be the opposite of the sum of those two absolute values, A and B. Okay, so now let's look at some examples of this, starting with finding the additive inverse of each of the following. Let's find the opposite of negative 3 plus x. Well, it's negative. The opposite, we just drop off that negative sign and just say 3 plus x as the opposite, as the additive inverse. Now for part B, a plus negative 4. Well, this is what I can do here. I can take the opposite of a, that's going to be negative a, and then plus the opposite of negative 4, which will be 4. So you'll end up with negative a plus 4. And then part C, negative 3 plus negative x. Just like I did in part A, part B, I can take the opposite of negative 3, that's 3, plus the opposite of negative x, that'd just be x. Okay. All right, on the next page is a homework example, similar to what's in the homework in my math lab. But find the additive inverse of each of the following integers. Write the answer in the simplest possible form. So in this case, if I wanted to find the opposite of 8, well, in that case, that's just simply going to be negative 8. Better yet, let me label this as part A and then write the answer, negative 8. Now, part B, the opposite of negative 5. Well, we drop the negative sign in front of the 5, it'd just be plain 5. Part C, the opposite of G. Well, it's positive G, so the opposite of that would just be negative G. Part D, the additive inverse or the opposite of 0 is 0. Part E, for negative C, the opposite of that, we drop the negative, that would be C. And F, let's say we have x plus y. Well, the opposite of x plus y, I'm going to put a negative sign in front of x plus y, and it will be in parentheses. So it'll be the opposite of the quantity x plus y, which is negative of the quantity x plus y. Okay, so that's how we find the additive inverse or the opposite of each of the following integers. All right, now let's look at integer subtraction. Integer subtraction is this. As with integer addition, we explore several models for integer subtraction. One of them, of course, would be the chip model. So to find 3 minus a negative 2, we add 0 in the form of 2 plus negative 2. That's 2 yellow chips and 2 red chips to the 3 yellow chips, and then take away the 2 red chips. All right, so as you can see in this illustration here, we got 3 red chips, and then here we're going to subtract by adding 2 zero pairs, 2 red chips and 2 yellow chips. That way we can subtract negative 2 from it, and you'll end up with 5 yellow chips, which will be 5. So that's 3 minus a negative 2, which would give us 5. Okay, but for us to subtract negative 2, we had to include those 0 pairs. 2 red chips and then 2 yellow chips. So in this homework example here, let's say I want to use a chip model to compute the following subtractions here. Starting with part A, -5 minus a -2. All right. And here I'm going to draw a circle. Now, for -5, I'm going to use 5 red dots. And I want to subtract -2. Well, in this case here, I can subtract -2 because I got 5 red chips for -5. I can subtract 2 of those red chips or red dots, take those out. And I'll be left with 3 red dots or -3. So it'll be -5 minus -2. That's going to be -3. Now part B, -4 minus a -2. Well, let's draw in 4 red dots for -4. And now we're going to subtract -2. Well, in this case, I got -2. Well, I got 2 red dots for -2. I can take that out. And I'm left with 2 red dots or -2. So -4 minus a -2 equals -2. Now part C, for 4 minus a -2. All right, since I don't have a yellow marker, I'll have to use green for positive. So I'm going to draw in 4 green dots for positive, okay? But I need to subtract -2. And I don't have 2 red dots. Well, I can put in 2 red dots, but if I do that, I need to add 2 green dots. So here I have to create 2 zero pairs. And now I can take away those 2 red dots, which represents -2. That can come out. So here 4 minus -2 is actually going to be 6 because I have 6 green dots. And part D, -5 minus 1. -5 is represented by 5 red dots. However, I need to subtract 1. I need to subtract a positive 1. I'm not going to be able to do that unless I add a zero pair. In other words, I need to add a green dot and 1 red dot to form that zero pair. So I can subtract a positive 1, which is this green dot right here. I can take that out. How many red dots I have? 6, which represents -6. So -5 minus 1 ends up being -6. Okay. All right, now we can also use the number line model for subtraction. We can use the number line model. Another model for subtraction of integers involves a number line and the idea of a cat walking the number line. Now here are the rules for walking the number line in this case. You always start at 0 facing the positive direction or the direction on the right side. If the number is positive, you walk forward. If the number is negative, you walk backward. Now, in this case, subtraction is going to be modeled by turning around and facing the negative direction, or facing the left when you subtract. Now, here's some examples of that, or some illustrations here that you see on your handout. Let's start with this one, 5 minus 3. This right here is 5 minus 3. And in this case here, the cat is facing to the right. So you start at 0. Positive 5 means you go to the right 5. We're subtracting, so here this cat will be facing the left, or facing the negative direction, and will be going 3 places forward to the left, facing the negative direction. We end up at 2. So that means 5 minus 3 equals 2. Okay. And this one represents negative 3 minus 5. Negative 3 minus 5. We stay at 0, but since it's a negative 3, we face the positive direction and walk backwards to negative 3. And we're subtracting, so this cat is going to be facing to the left. And then 5 is a positive 5. You go ahead and go 5 places in this direction. So you end up with at negative 8. So negative 3 minus 5 equals negative 8. Okay, now this next illustration is negative 3 minus a negative 5. All right, so we start at 0, facing the positive direction. We walk backwards 3 because it's negative 3. And then we're subtracting, so the cat will be facing in the negative direction, like this. And then then that cat's going to be walking backwards 5 because it's negative 5. So we walk backwards 5 places. We end up at positive 2. So negative 3 minus a negative 5 would be 2. And then finally, we have 3 minus a negative 5. That's what this illustrates. And by the way, notice I put the parentheses around the negative 5 to separate the minus sign from the negative. Sometimes they use the raised negative symbol to avoid confusion. All right, there's a positive 3. We start at 0, facing in the positive direction, and walk to the right 3 places. We're subtracting, that means we face the negative direction. And then from 3, we're going to be walking backwards 5 because it's negative 5. We end up at 8. So 3 minus a negative 5 ends up being 8. So that's how we use that number line method to subtract integers. Okay. Now let's look at this homework example number 5, using that number line model to compute the following subtractions, like -1 minus -4. Okay. Okay, now I'm going to use some type of model here, like this arrow right here, where I got R for right and L for left. Okay. So for -1 minus 4, we're always going to be facing to the right in this case. and it's -1. So that means we walk backwards to 1, like this. Now the minus sign, we're subtracting, so that means we need to be facing this direction to the left. So notice I switched from right to left. And then for -4, it's a -4, so we need to walk backwards 1, 2, 3, 4. And notice that we ended up at +3. So -1 minus 4 is equal to 3. All right, part B, we got -1 minus a -5. All right, -1 minus a -5. We start at 0, we face to the right. Now, -1 means we need to walk back 1 place. The minus sign, subtraction, means I need to be turning this way, facing to the left. And this time I have -5, so that means I walk backwards 1, 2, 3, 4, 5 places. I ended up at 4. So that means -1 minus a -5 would be 4. And now part C, 2 minus a -3. All right, so I'm going to use this pointer here. Yes. Start at 0, facing to the right, and it's a +2, so I'm going to go to the right 2 places, 1, 2. Now we're subtracting, so that means I switch from right to left, and then I'm going to go backwards because it's a -3 places, 1, 2, and 3. And here we ended up at +5. So 2 minus a -3 equals 5. And then part D, we got -2 minus 2. All right, we start at 0, facing in the positive direction, which is to the right. -2 means I walk backwards 2 places. So I end up at -2. Minus means switch this way is a +2. So I'm going to be going in this direction 2 places. I walk forward 2 places. I end up at -4. So -2 minus 2 is -4. Okay, so that's how we apply that number line model to do problems like this, to subtract integers. Okay. Let's say we had this, y equals -x minus 9. And I want to find the value of y when x is equal to -5. So in this case here, I'm going to have y is equal to, bring over the negative, substitute your x with -5. So the y equals negative of -5 minus 9. Well, the opposite of -5 would be 5, and then 5 minus 9. And if you want to use this model, this number line model that I have up here, start at 0, facing to the right, +5, I go to the right, 5, I end up here. And then subtraction means I switch from right to left and go forward 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. I ended up at -4. So that means y is equal to -4. Okay. All right, on the next page is a pattern model for subtraction. Here we can use inductive reasoning and starting with known subtraction facts to find the difference of two integers by following a pattern. Like 3 minus 2, that's going to be 1. 3 minus 3 is 0. 3 minus 4 would end up being -1. So as you can see, as we increase the second number by 1, the difference decreases, or in this case, well, it decreases by 1 in this case. Now, in this situation, the subtrahend or the second number decreases by 1, which makes the difference increase by 1. Like 3 minus 2 is 1, 3 minus 1 would be 2, 3 minus 0 is 3, then 3 minus a -1 will have to be 4. So as you can see, as the second number decreases by 1, the difference increases by 1. Okay. Next is the definition of integer subtraction. For integers a and b, a minus b is a unique integer such that a is equal to b plus n. And that unique integer is going to be n, such that a equals b plus n. So that means we need to find a number where that number plus the b would give us the a right back. Like in this case here, here's a couple of examples of this. Let's use that definition of subtraction to compute the following. 3 minus 10. So that means I need some number added to 10 that would give us 3. Well, I know this. It's got to be a negative number because some number plus 10 is going to give us this number that's less than 10. So I know if 10 plus 3, if 3 plus 7 gives us 10, then that means -7 plus 10 must give us 3. And besides, we're subtracting a bigger number from a smaller number, so that means that that missing number has to be a negative number. And this number here, this difference, -2 minus 10, that would mean some number plus 10 must give us a -2. And let's think about this for a moment here. Well, if I get a -2, that means that this number has to have a greater absolute value. And it'll have to be like -12, because -12 plus 10 does give me -2. Okay. All right. Another approach would be just subtracting by using adding the opposite approach. Subtracting the integer is just the same as adding the opposite. So that means if I have a minus b, then I can write that as addition problem by changing subtraction to addition and changing the b to the opposite, which is -b. So I have a plus -b. And then I apply the rules for adding integers. Okay. So subtracting the integer is the same as adding the opposite. And we're going to look at a few examples just like that. Like this one. We're going to use the fact that a minus b is equal to a plus -b to compute each of the following, starting with part A, 2 minus 8. Well, in this case here, I'm subtracting 8. That would mean the same as saying 2 plus the opposite of 8, which is -8. And then I apply the rules for adding two integers with different signs. We subtract and take the sign of the larger. 2 from 8 will be 6. The larger absolute value has the sign of negative, so the answer has to be negative. Part B, 2 minus a negative 8. 2 minus a negative 8. That's the same thing, 2 plus the opposite of negative 8, which is positive 8, which is 8. And now we just add 2 plus 8. That's just going to be 10. Part C, you got negative 12 minus negative 5. Here we're subtracting a negative 5, so I'm going to bring the negative 12 over. This would be addition. Then the opposite of negative 5 would be 5. And then 12 plus negative 5, well, we're adding two integers with different signs. So we subtract 5 from 12. That's 7. The larger absolute value has the sign of negative, so that means the answer has to be negative. So negative 12 minus a negative 5, negative 7. And then negative 12 minus 5. Well, I'm subtracting 5, so that means that's the same as adding the opposite of 5. That's negative 5. Well, I'm adding two integers with the same sign, so I can add 12 and 5, that's 17. Get that answer the same sign. So it'll be negative 17. Okay. Now let's look at this example. Let's say we want to rewrite each expression without parentheses. Okay. Like negative and in parentheses B minus C. Well, in this case here, that negative, I can take the opposite of B, that'd be negative B, minus the opposite of C. That'd be negative C. Okay, and I'm subtracting a negative C, so I bring over the negative B, and then change subtraction to addition, the opposite of C, opposite of negative C, which will be C. So I'll end up with negative B plus C. And then part B, A minus, and in parentheses, B plus C. Well, let's bring over the A. Now, in this case here, the opposite of B would be minus B, and then the opposite of plus C would be minus C. And I'm sure they probably want it to be written like this, adding negative B and adding negative C. Okay. Now here's some more examples of this. Say we want to simplify each of the following expressions here. 2 minus, and in parentheses, 5 minus x. Bring over the 2, the opposite of 5 would be just adding negative 5. And then, let's see. Let me write it like this. Since we're subtracting 5 minus x, the opposite would be plus, and then the negative outside, and then 5 minus x. And then in this case here, the opposite of 5 would be negative 5, minus the opposite of x would be negative x. So I'm going to leave this as 2 plus negative 5, and then the opposite of negative x would be plus x. And then if I add 2 plus negative 5, subtract 2 from 5, that would be 3, but the sign of the larger is negative, so the 3 would be negative. So it'd be negative 3 plus x. Or x minus 3. And then for part B, 5 minus, and in parentheses, x minus 3. Bring the 5 over. This will be plus the negative of x minus 3. And the opposite of x will be negative x. And then minus the opposite of 3 will be negative 3. Bring this over. Minus a negative 3 will be plus 3. Then if I add 5 plus 3, that will be 8 plus negative x. Or we can say x minus 8. 8 minus x as the final answer. And then negative, and in parentheses, x minus y. Okay, treat this as the opposite of x. That's negative x. And then minus the opposite of y, which would be negative y. And then we add to it negative y, which is subtracting y. So that's the opposite, adding the opposite of y, which is negative y. Let's see, negative x. The opposite of negative y would be plus y. Now, if I have y and a negative y added together, I get a 0 pair, and I'll be left with negative x. Okay. Now let's look at a homework example similar to that. Simplify as much as possible. Start with part A, 6 minus, and in parentheses, 3 minus 2x. Now, if you want to, you can just go do this straightforward. Bring over the 6. Then minus would be the opposite of 3, which is minus 3. And then the opposite of minus 2x would be plus 2x. If it's easier to do it that way. And now, if we do 6 minus 3, that would be 3 plus 2x. And that's as far as we can go with that problem. The same with part B. X minus, and then negative x minus 3y. Bring this x over, take the opposite of negative x, that would be a plus x. Then the opposite of minus 3y would be a plus 3y. And now I got 1x plus another 1x. That would be 2x plus 3y. Okay. All right. Now, recall that subtraction is neither going to be commutative nor associative. An expression such as 3 minus 15 minus 8 is ambiguous unless we know in which order to perform the subtractions. Mathematicians agree that 3 minus 15 minus 8 means this. You do 3 minus 15 first and then subtract 8. So here subtractions are performed in order from left to right, like in this example. 2 minus 5 minus 5. So if I do the 2 minus 5, of course, that would be negative 3. Negative 3 minus 5, negative 8. So think of 2 minus 5 as 2 plus negative 5, and then the minus 5 would be plus negative 5. And just go from left to right. You should get negative 8. All right, and now 3 minus 7 plus 3. Think of this as 3 plus negative 7 plus 3. Going from left to right, 3 plus negative 7 would be negative 4. Negative 4 plus 3 would be negative 1. Now, part C, you got 3 minus, and in parentheses, 7 minus 3. This time, you're going to do what's in the parentheses first. Do the 7 minus 3, which is 4. So you'll get 3 minus 4, which is the same as 3 plus negative 4. It's adding the opposite. You'll get negative 1. Okay. Here's a homework example like that. Let's say we had negative 9 minus 6 minus a negative 18. All right, let's do this. I'm going to bring the negative 9 over. Subtracting 6 is the same as adding negative 6. Subtracting a negative 18 is the same as adding the opposite of negative 18, which is 18. And now we go from left to right. If I add negative 9 to negative 6, I will get negative 15. Negative 15 plus 8 would be 3. And that would be the final answer to that. Okay. Let's say we had some equations that had negative integers in them. Let's say we want to solve the following equations, like in part A, x plus 4 is equal to 1. Well, to solve for x, I'm adding 4. So let's add the opposite of 4, which is negative 4. So I'm adding negative 4 on both sides. So the negative 4 added to its opposite is 0. So you'll be left with x, and that's equal to negative 1 plus negative 4. It should give you negative 3. All right, and then part B, we got negative 5 plus x equal negative 4. And let's solve for x. We got negative 5 added to it, so the opposite of adding negative 5, well, the opposite of negative 5 will be 5. So I'm going to add its opposite on both sides. This gives me 0. I'll be left with x, and then negative 4 plus 5 is 1. So here, it'll be x is equal to 1. Part C, negative x equals 6. And let's say I want to solve for x. Well, let's take the opposite on both sides since I got the negative sign in front of the x. And I'm just taking the opposite on both sides. Well, the opposite of negative x is x. So the opposite of 6 will be negative 6. So that means x is equal to negative 6. Okay. All right, so the next homework example that we have here deals with absolute value equations. And recall, anytime you have the absolute value of x equaling to some constant a, this means we need to write that as two equations. X is equal to positive a, or x is equal to negative a. So in this case here, we got the absolute value of x minus 11, and that's equal to 11. So with this, we're going to write this as two separate equations. One equation will be x minus 11 equals 11, or x minus 11 equals negative 11. So we have to write two equations using this format right here for absolute value equations. All right, so if I take that first equation, add 11 to both sides, that would mean x is equal to 11. And then for x minus 11 equals to positive 11, if I add 11 to both sides, that would mean x is equal to 0. And correction on this first equation. 11 plus 11 should be 22. Okay. So my two solutions are 0 and 22. Now for part B, I got the absolute value of x, and then plus 4 is equal to 11. Yeah, I need to get the absolute value of x by itself before I write my two equations. I'm adding 4, so the opposite of 4 would be -4. So we'll add -4 on both sides, which means I have the absolute value of x, and then that's equal to 11 plus -4 would be 7. So I have the absolute value of x equals to 7. Now I need to write my two equations like these here. Absolute value of x equal to 7 means x is equal to 7, or x equals -7. And those are my two solutions to this absolute value equation, 7 or -7. All right, now we got an absolute value of 19x is equal to the absolute value of -19x. Okay, I'm going to simplify the right side because notice I got a negative sign here in front of the 19x. That means -1 times 19x inside the absolute value. I can take the absolute value of -1. Here, the absolute value of -1 is 1. So that means I'm at the absolute value of 19x equaling to the absolute value of 19x. And I'll go no further than this because both the left side and the right side of this equation are exactly the same, which means any x value that I assign to it, the left side will always be equal to the right side. So I can say for this one that all integers, positive, negative, and 0, satisfy this equation. All integers satisfy this equation. All right. Now, on the next page are just a couple of application problems here. In each of the following problems, you're going to write an additional subtraction statement and then solve the problem. So in this case here, in part A, the hottest temperature ever recorded in a certain state was 120 degrees Fahrenheit. It was recorded on July 6, 1936. Less than 5 months earlier, on February 15, 1936, the lowest temperature in the state's history was -61 degrees Fahrenheit. What is the difference between the hottest and the lowest temperature? Okay. So here I want to write this as an additional subtraction statement. Hottest temperature was 120. And we're looking for the difference between the hottest and the lowest. So we have to subtract the lowest temperature, which was -61. So that's our subtraction statement in this case, 120 minus a -61. And let's solve this problem. Well, we're subtracting a -61, so that means that's the same as say 120 plus 61, which will end up being 181. So the difference between the hottest and the lowest temperature is 181 degrees. Part B. The temperature was -5 degrees Fahrenheit, and then it rose 15 degrees Fahrenheit. What is this new temperature? Well, an addition statement for that would be -5, because that was the temperature to begin with. and then it rose 15 degrees plus 15. So that would be the addition sentence. Well, we're adding two integers with different signs. So we subtract 5 from 15, that would be 10. 15 is the larger absolute value, is positive, so it'll be positive 10 as the answer. Now, part C. The temperature went down from 44 degrees to -3 degrees Fahrenheit. How many degrees did the temperature fall? So started off as 44 degrees, went down to 3, so to -3, so it'd be minus -3. So that would be the subtraction sentence in this case, 44 minus -3, which is the same as writing it as 44 plus the opposite of 3, -3, which is 3. So 44 plus 3 will be 47. Part D. Brooke's house had a temperature of 54 degrees Fahrenheit. She put the heat on and the temperature rose by 11 degrees Fahrenheit as she was still cold. Brooke lit a fire which increased the temperature by 10 degrees Fahrenheit. What was the temperature in the house then? Okay. So it was 54 degrees to begin with. Put the heat on, it rose by 11 degrees. She lit a fire, it increased the temperature by another 10 degrees. So it'd be 54 plus 11 plus 10. Add those numbers together, you'll end up with 75. So the temperature in the house then was 75 degrees Fahrenheit. Okay. And here's another application problem dealing with integers. In each of the following problems, you're going to write an addition or subtraction statement and then solve the problem. Like this one, Carlos spent too much money and had a bank account balance of -$52. He deposited his $160 paycheck. How much money did he have then? So in this case here, his bank account balance was a -$52, but then deposited his paycheck of $160. So that's the addition sentence, -52 plus 60. Well, we're adding two integers with different signs. So we subtract 52 from 160, that would be 108. The larger of the two absolute values is 160 is positive, so 108 will be positive. So the amount of money he had then was $108. Part B. Tara has $43 in the bank. She spent $64 on shoes. By how much was she overdrawn then? She had $43 in the bank. So she spent 64 on shoes. So that's minus 64. So it'd be 43 minus 64. And to find out how much was she overdrawn then? Well, 43 minus 64 is the same 43 plus the opposite of 64. That's -64. I'm adding two integers with different signs. So if I subtract 43 from 64, that would be 21. The 64 has a negative sign, so the answer has to be negative. So here she's $21 overdrawn. Now part C. Jenna was given $80 for her birthday. She bought a pair of sunglasses for $55 and a purse for $42. How much was she in debt? $80 was given on her birthday, so that's 80. Bought a pair of sunglasses for 55, so that means she spent $55, that's minus 55. She also spent $42 for a purse, that's minus 42. So that's the subtraction sentence, 80 minus 55 minus 42. Now, let's find out how much was she in debt. 80 minus 55 if we subtract that, that would be 25. So it'll be 25 minus 42. That's the same as saying 25 plus the opposite of 42, which is negative 42. Adding two integers with different signs, subtract 25 from 42, you'll get 17. The 42 is negative because it's the larger of the two absolute values, so the answer has to be negative. So in other words, she is $17 in debt. And part D. Martin was $59 overdrawn. Then he had to spend $238 on his car. How much was he overdrawn then? So $59 overdrawn as an integer would be negative 59. He spent $238, so it's minus 238. So that's the subtraction sentence. So it'd be negative 59 plus the opposite 238 would be negative 238. So here we're adding two integers with the same sign. So we add and keep the same sign. So we add 59 and 238, that'd be 297. Both signs are negative, so the answer would be negative. So in other words, he was overdrawn $297. Okay. And the final homework example in this video. A football team lost 26 yards on their first play and gained 21 yards on the next play. Express the total yards gained or lost as an integer. So if I write an addition or subtraction sentence, they lost 26 yards on the first play, so that's negative 26. They gained 21 yards on the next play. That'd be plus 21. We're adding two integers with different signs. So we subtract 21 from 26, that will leave us with 5. 26 is the larger absolute value and it's negative, so we give that answer that sign, negative 5. So in other words, the football team on 2 plays lost 5 yards on 2 plays. Okay, so that does conclude this video on addition and subtraction of integers. Feel free to email me or call me if you have any questions about anything that's presented in this video or any of the problems that are in my MATLAB for section 5.1.